Hey guys, sorry our previous video got interrupted due to my receiving a phone call. So we're back and we're still talking about boiling points and what factors affect them and how can we explain the differences in boiling points of various substances. So we last talked about propanol or acetone with boiling point, normal boiling point of 56 degrees. So quite a high jump, quite a large jump from propane to propanol. One of the reasons is an extra oxygen here, but also very importantly is presence of this polar C double bond O. So here you have a polar oxygen. Polar oxygen as a result will have partial negative charge. Carbon, of course, this carbon here will carry partial positive charge. And therefore, this molecule can be imagined as a dipole. Therefore, in addition to London or dispersion forces, propanol would be expected to have dipole-dipole interactions, which are fairly strong type of intermolecular interactions, resulting in an increase of the boiling point. Finally, the last substance on the list to consider is propanol. I'm still sticking, as you can see, with 3 carbons and only 1 oxygen, just like in propanol. So the difference in molar masses between these two is minuscule, very, very close. However, if you look at the magnitude of boiling point for propanol, you will see it's actually 100 degrees Celsius. So another almost 50 degrees jump. It's a very large increase. So how can we explain that type of an increase? And our attention, of course, should be drawn to this OH group, which is an alcohol group, where you have hydrogen directly attached to oxygen. You also have oxygen connected to carbon, having a polar bond here with oxygen still carrying partial negative charge. So what type of intermolecular interactions would we expect in propanol? Well, definitely London or dispersion forces. Also dipole-dipole interactions due to CO bond, but also on top of those two, there is hydrogen bonding. And because hydrogen bonding is present in propanol, but not propanol, because in propanol, there is no hydrogen directly attached to an oxygen like we have in propanol. And so this substance here will have the highest boiling point of 100 degrees. So this is the type of explanation I would be looking for in the quiz, where you look at a particular molecule and you decide what type of intermolecular interactions it has, and you list them and you explain why each type of intermolecular interaction is present. Now to actual measurement of boiling point. Since you have never done this before, I would like to show you how you're going to do this. You're going to take a large test tube from your drawer, make sure it's clean and dry, no water should be present. You're going to place about 2 milliliters of liquid. I believe your procedure calls for 1 milliliter. We're going to double it to 2 milliliters. It's going to be about this much into the test tube. You will then take a regular alcohol thermometer, and rubber bands will be provided in the lab, and you're going to place the thermometer next to the test tube. And you're going to use the rubber band, holding them tightly like this, to wrap the band tightly around the test tube and the thermometer, and then you're going to pull it up. The goal is to have the thermometer to be on the side of the test tube, and you want the bulb of the thermometer to be lined up with the bottom of the test tube like I have here. As you can see, they're just on the same level. This assembly is going to be placed in the water bath. Now I want to talk to you about the water bath. You'll probably use a 400 milliliter beaker or 600. This is a 400. It might be appropriate, or maybe 600 would be even better. Make sure the bottom of the test tube as well as bottom of the thermometer is sitting at least an inch away from the bottom of the beaker. You're going to fill the beaker with water so that water in your water bath would be above the level of liquid in the test tube. So the entire sample of liquid in the test tube must be submerged in the water. But once again, the bottom of the test tube should not be too close to the bottom of the beaker because this will cause overheating. You will then carefully heat the setup with a Bunsen burner. The burner is preferable here because it provides much better control and allows you to stop heating whenever necessary. In order to know when boiling is actually starting to occur, so you can take a temperature reading, you're going to use a special capillary tube. You will see tubes like this throughout the lab. In this tube, you will find what's called a capillary tube, specifically melting point capillary tube. As follows from its name, it's used to mainly measure melting points of solids, and you'll be doing that when you take organic chemistry. One end of the capillary tube is sealed, while the other end is open. So it's important to position the capillary tube correctly, and I will probably remind you of this when you start working on this experiment. You want to turn the capillary tube in such a way where sealed end is pointing up while the open end is pointing down. And then before you start heating your liquid, you're going to carefully drop the capillary tube into the test tube so that open end is sitting on the bottom. And then you're going to start heating. Now initially, what's present inside the capillary tube is of course air. But then as you start heating the liquid, more and more molecules of the liquid will become vapor, and some of these vapor molecules of liquid will enter the capillary tube and will start forcing the air out of the capillary tube. You're going to be carefully watching right there the bottom of the capillary tube, and you're going to wait for a moment when tiny little bubbles start escaping this open end, several minutes, very quick succession of bubbles, not just one stray bubble and then nothing happens for several seconds. Quick succession where several bubbles may even come every second. That's when you start, take your first temperature reading, start reading temperature. And then at some point when all the capillary tube is filled with liquid, liquid will go, all the air, I should say, is out of the capillary tube, liquid will go in. And that's typically the second reading you would take. So your boiling point that you record would be the average between two temperatures. First temperature is when bubbles come out quickly, and then typically bubbles would stop coming out briefly, and that's when liquid goes in. It is admittedly very hard to see when liquid does go in the capillary tube, but you should be able to notice when bubbles start coming out quickly, so that should be your best indication that boiling is taking place. Couple of things to keep in mind. One, proper positioning of the setup in the beaker. Not too close to the bottom, not to allow overheating, with water in the beaker completely covering the liquid in the test tube. Now, if you notice the temperature is starting to get to 100, most likely you've missed your boiling point, because most of the liquids are organic liquids, so their temperature, their boiling point, excuse me, will be below 100. So watch out for that. Also, you will have to do 2 trials of this experiment, meaning once you get your first boiling point, you need to turn off the gas, let the setup cool briefly, carefully using a hot mitt, remove the, lift the test tube held by the clamp first, then take the beaker with the hot mitt, and then carefully pour out hot water from the beaker into the sink, and then refill the beaker with cold water again, and replace the setup and begin your second determination. Now, majority of these liquids you're working with, being organic liquids, are volatile. Well, some more than others, but majority are highly volatile. So it may be that most of the sample will have evaporated during the first trial. Make sure to let the entire setup cool, and then add more liquid if necessary, but only to the cold test tube. Do not add more liquid to the test tube that's still hot after first determination, and do not begin your second determination with barely any liquid present in the test tube. There has to be enough of the sample. If only very little liquid left, it may all evaporate when you begin heating again, and this may cause the fire to start right above the test tube, because the vapors will be what catches on fire. So make sure to keep that in mind. Finally, the heating should be done slowly, so you'll need to adjust your Bunsen burner to slowly heat the water, and you will need to use your stirring rod to carefully stir the water around your test tube in order to ensure the temperature is consistent throughout the water bath. So hopefully I gave you enough information to successfully complete this experiment.